Jim Crowder. Dr. Crowder is not a stranger here. In recent years, he has delivered keynote talks at this Congress. I'm honored to have this opportunity to welcome him again. Dr. Jim Crowder is an engineering fellow at Colorado Engineering Incorporation. Dr. Crowder's career spans over 35 years of experience in engineering, 25 of which has been in artificial intelligence. Having fielded his first neural network system in 1993 and his first fuzzy system in 1995, advanced computing and artificial intelligence has been his focus across Lockheed Martin, Northrop Grumman, Raytheon Technologies, and now a small engineering firm in Colorado Springs, Colorado Engineering Incorporation. Dr. Crowder holds a PhD in electrical engineering, 2 master's degrees, one in electrical engineering and one in applied math, and a BS in electrical engineering. He has designed and fielded multiple artificial systems for most of the Department of Defense agencies, including DARPA, Air Force Research Labs, the Navy, and the Army. He has published 6 books. Some of the books are outside. We put them at the exhibition table. They are there for your review. They are not for sale. The books are on systems engineering and artificial intelligence, and they are published by Springer. And they are used as textbooks in some universities. He's currently under contract for a new textbook on requirements in management. Dr. Crowder has over 120 journal and conference publications and continues to be a leader in the field of artificial intelligence, evolutionary algorithms, fuzzy systems, cognitive architectures, and machine learning. His groundbreaking work in artificial psychology, or the psychology of artificial intelligence, has been downloaded and read over 17,000 times and continues to be a major download from ResearchGate with close to 100 downloads weekly. He's a leader and a visionary in AI. His contributions have inspired the research community at large, including all my 11 PhD students. One of them just talking about the demo. One of them just graduated last week, Dr. Emilian. And I'm also honored to know him as a good friend. Jim, it's all yours.
Good morning.
Good morning.
You can all hear me in the back. I'm not going to worry about a microphone. Okay, good.
Jim, maybe have it keep it on. You make it edited. Just keep it on. You don't need to. You do not need to.
Okay.
Just put it down. Keep it on. Still be up.
Okay.
Thank you.
So, AI has been around for a long time. It's now pervasive in pretty much everything we do. Your cell phones, your computers, your cars, everything. There's now AI chips in air fresheners. Everything has, matter of fact, nobody wants to be the guy or girl whose project doesn't have AI. There's a stigma about not having AI. We pushed more and more and more to get more cognitive and smarter systems. I keep hearing DARPA, Air Force tell me we want systems to learn and think and reason like people. My first question is, what people? Stephen Hawking or Stephen King? They're both people. They both learn to think and reason, but maybe a little differently. So what is it you really want? Well, they want things that can learn and reason, okay? So you're okay with them making mistakes? No, you're not. And as we push harder and harder and harder for more cognitive things, we have to try and understand how to put the right constraints How many here have seen at least one Hollywood movie where the AI went wacko and tried to take over humanity? How many have had one that doesn't? No. Okay, Hollywood is replete with doom and gloom of AI. Even Stephen Hawking warned us about AI. And we need to take that into account. So the question is, how do I put constraints on an AI system? How do I put filters? How do I put objective functions? What do I do so that it still acts like kind of a human, but doesn't do things we don't want? Because after all, humans never do things we don't want. Now, a lot of people will go to Asimov and say, well, Asimov, didn't he solve this? Asimov's 3 robotic laws? Certainly those should help us. Let's talk about those. Many believe they're appropriate. Matter of fact, they call them robotic laws, not robotic suggestions, not robotic guidelines. They call them robotic laws. Let's talk. Matter of fact, you can see the robot bringing Asimov's laws down from the mountain. But let's talk about that. Law 0 and 1. Robot cannot harm another human or by its inaction allow a human to be harmed. How many people in here have ever heard of one human harming another one? Happens pretty much every day. So if I'm a robot and I do nothing, I'm violating the first law because I watch humans harm other humans. But how do I stop humans from harming other humans and not harm humans? Wait, I could lock you all up in cages, feed you through the door, and as long as I don't harm you and you can't harm each other, I'm good. Now, I don't think that's what this robotic law was intended to be pervasive and do, but you know what that means? And I must obey orders given by human beings, except where it violates the first one. Now, the nice thing about that is I've never seen 2 humans that disagree on anything. Therefore, obey humans, except when they disagree, which is always. And the purpose of this is not to ditch Asimov. It's just to understand that subtleties in how we deal with AI systems, cognitive systems, have long-standing effect. And we have to be careful. Now, I like his question. I don't harm humans, but what if the humans are really, really harming? Now, a lot of people have tried to put that in perspective, and there's now laws of human-centered robotics. The DoD, which we're going to talk about in a minute, has their own rules for how to deal with AI. So here's a human-centered 3 laws of robotics. These are on the books, the DoD. Human-centered robot will not replace humans. Only forms of human labor that are dangerous, repetitive, and exhausting. Now, if it's a cognitive self-aware robot, is it going to like that? No. So this is obviously not for cognitive robots. These are for dumb robots. If I'm a cognitive robot and I see you treating dumb robots badly, I may react. Who knows? Human-centered robot assists human beings and protects its own existence as long as it doesn't violate the first principle. Again, problematic. Now, if I think about it from a robot-centered view, what would my 3 laws be? A, always carry a spare battery. B, never show emotions. And C, make sure humans think they're in charge. How many here are familiar with Futurama? Okay, you'll notice Bender. Can you not see Bender saying that? Humans are in charge until they're not. So here's the Department of Defense's, again, this has been put together by a DoD committee. He understands. DoD personnel will exercise appropriate levels of judgment and care while remaining responsible for the development of AI. How many different definitions of appropriate do you think there are? How many people are in this room? Maybe 60, 70? I want you to bet we get 90 different definitions of appropriate out of this group. Remaining responsible. What does it mean to remain responsible? We have no idea. So while this is on the books and it's made to temper how we use AI, does it mean anything? Somebody tell me. It means nothing. The department will take deliberate steps to minimize unintended bias. How do you measure unintended bias? Anybody answer me? If it's unintended, it's probably undetectable until it's not, and it's a problem. Relevant personnel with an appropriate understanding of the technology. What does it mean to have an appropriate level of understanding of a given technology? Does that mean 6 months experience, a year's experience, a master's degree into the PhD and tenure? What does that mean? Nobody knows. Reliable. Shall have explicit, well-defined uses, and safety and security and effectiveness. Now that's an easy one to measure. What's an effective AI? Somebody tell me in general what AI is supposed to do. You can't, because it depends on what it's supposed to be doing, what application it is, what environment it's in. And again, I'm not here to ditch the DoD. I'm just trying to understand the people have spent years carefully crafting rules for AI that make no sense and mean nothing. So, what does it mean to provide ethics to an AI? What does it mean to put controls on an AI? How many people here feel an AI from China versus Russia versus Israel versus Egypt versus the US would all have the same ethics? Yeah. So what we need to do is we need to provide cognitive AI with the ability to make reasonable choices. I don't know what reasonable means. First of all, here's a question. What does it mean for an AI to be working right?
It
Depends, doesn't it?
as long as it makes less mistakes than a human does doing the same job. Or quicker.
So for an AI to be working, particularly a fully cognitive, self-aware robot, what does it mean for it to be working correctly? What does it mean for it to be working incorrectly? Let's ask that about a person. What does it mean for a person to be working correctly? If he's a scientist versus a mechanic versus a plumber versus a CEO, which one's correct? You can't answer that question. Is there one of them that's not correct? It depends on the person. So we can't even define what it means for AI to be working correctly. So trying to understand how to control it, how to put controls on it, how to put constraints on it, keep it from going wackadoodle, which all AI and Hollywood does, is essentially we need to spend as a community considerable time thinking through. It needs to come up a level as a technical community across the globe to discuss. because we're gonna start putting AI, smarter and smarter AI in the field without thinking through these things, and disasters are going to happen. Anybody think it's possible to build an AI without any cultural bias involved? I think the answer is no. And what could be the problem with unintended bias? What? So, now we start looking at things. So how do you build in ethical constraints into an AI? What does it mean to be ethical? Benefits the maximum number of people. Now, if you're one of the people who aren't one of the maximum number of people, are you okay with that? Probably not. Let's talk about self-driving cars. Built into the construct of a self-driving car is a statistical model that says if the car's going to have an accident and veering left kills 4 people, veering right kills 3 people, going straight only kills you, you're expendable. Are we all okay with our car deciding that we're expendable? Probably not, but that's in the software. So what do? Human rights, preserve the rights of all people. Does everybody across every country agree what it means to secure the rights of all people? No, we don't. So again, even ethical rules we would all agree on are really tough. Write software that does that. Common good. Protect the common good. There's only one definition of common good. Yes? Again, if I go to each different country and within country start polling people, I'm going to get 1,000 different definitions of what common good means. Doesn't mean any one of them is good or bad. It's just different. And if your robot's common good and your robot's common good are different, we're going to have issues. So, I started thinking about, rather than build rules in, we were talking about this earlier. Consumer Electronics Show 2 years ago. Japanese company had a set of autonomous robots they brought to Consumer Electronics Show. They had one of them out on the street, maneuvering down the sidewalk to show it could maneuver around people. It mistakenly wandered into the street it wasn't supposed to and got run over by a Tesla self-driving car. So right out of the gate, we had problems. Now, the robot wasn't supposed to wander into the streets. It did something it wasn't supposed to. The Tesla car shouldn't have been hitting anything. Why did it do that? Nobody ever thought of a robot wandering into the street in front of a self-driving car. Brings us the problem of trying to build rules, hard and fast scripts and rules don't work. Somebody write me a use case for every stupid thing a person can do. Can't do it. So the notion of I can train a neural network with enough data to handle every possible case a self-driving car is ever going to see, or a human-centered robot's going to see, can't happen. It will never happen. Tesla spent 2 years training the neural networks with self-driving car, and what's the first thing it did? Ran over a robot. So I started thinking about and trying to put together what kind of constructs can we use? And how do you simplify it? Because I can say, there's this great complicated thing I want to give a robot, But ask John, some poor software guy's got to code it. So how do we simplify it? How do we provide a simplified model to be able to make decision-making process? Because giving rules isn't going to work. Giving it a cognitive framework that lets it examine and make decisions is a possible way to roll. Now, what's the problem with that? The nice thing about humans as they grow up is they never do anything wrong. They never do something wrong and learn from it. Well, that's how we learn. Wisdom comes from experience. Experience comes from making bad decisions. So, how do I examine what's in front of me? How do I put it in context? Talking about thoroughly comprehending possible alternatives is put in context. Just taking in data doesn't help. I understand the context of what that data means at that time. Because the same data in a different environment could mean entirely different things. Here's a good example. He was talking about he came down from Salt Lake City, drove down, and as he's headed across the desert, I assume,
Yes.
a microburst hit and dumped tons of ash and dust onto the highway, blurring vision in how many cars?
20 vehicles.
20 vehicles involved and actually killed 7 people.
At this point, fortunately, we were early. We missed this.
Okay, so how many think a self-driving car would be able to maneuver that? Think anybody wrote a use case for a microburst of sand and silt crossing? No, nobody ever did that. Hypothesize. This is an important construct that AI people don't think about. Understanding machine learning and neural networks is, how do I create hypotheses based on the data I've taken in? Here's what it might mean. Let's start taking more data, figure out what we think it means, what it's most likely to mean, and then try to make decisions based on that. Because again, the same data in different situations means different things, requires different decisions, different actions. Compare and evaluate the arguments for each alternative. Choose it, act on it. And what's the most important thing about all of that? Learn from it. Yeah, people can do that very well. So I started looking at, is there a framework that's built around that kind of construct? Fortunately, the answer is yes. It's what the DoD, Department of Defense, calls the OODA loop. The OODA loop is utilized in every branch of the DoD. I'm assuming you're familiar with OODA loop. I've seen them spend $10 million to speed up the OODA loop by 10 minutes. Very important. OODA loop means observe or take in sensor data. Orient, which means find the context that data means. Make a decision and act on it. Now what's missing from the OODA loop is what's in the center. It's we should be learning from every single piece of this. I make observations. I should learn what those observations and how to better judge the observations. Our senses, our eyes, ears, nose, mouth, all of our senses throw away approximately 95% of everything they take in right in front. In our sensory memory, we throw away about 95% of the data that comes in. Which 5% does it keep? Depends on what your brain thinks is important at that moment. How many people here can remember scenes from their childhood? Okay. Can you envision yourself sitting on a lawn at your house? Do you see the lawn? Okay. Do you think your brain memorized every blade of grass in your lawn for that memory. But does your brain construct that lawn for you and show it to you in your memory? We keep what's important, we put tags to it. And we use it when we understand the brain doesn't remember things. The brain constructs memories from millions and billions of information fragments instantaneously and provides it as a memory. Some of which are explicit memories, some of which are implicit memory tags based on context. I'm trying to remember sitting on a lawn, oh, there better be a lawn. Now, if there's something about that lawn that was important to you, like a fountain in the middle of it that your dad built, or a wagon that you loved that was sitting on the lawn, that might have been remembered. But we build contextual memories. So I took a look at what would it mean to try and build this framework into a cognitive AI entity. And could this be a way to start to now understand? I'm not giving you an answer. I'm telling you some of the questions we need to start asking as a community. And you guys, particularly all the students out there, new PhD students, are going to become the technical community that have to solve this. We need to start thinking about it, talking about it. So, observe, examine the dilemma. Orient, thoroughly comprehend what it means, what's the context of it. Because what I decide radically depends on the context on which the data was taken into the situation. Hypothesize what arguments, investigate comparative. Decide. Once you make a decision, you act on it, but you then try to learn from it. What does it mean to learn from it? How many people think there's one kind of learning? No, there's not. There's multiple kinds of learning. In artificial intelligence, we tend to rely on neural networks too much. What is a neural network? It's a data classifier. That's all it is. If I put data in and tell it to learn from that data, and I give it things that are like that, it'll tell me it found that. That's all it is. My colleague, Dr. Tarbot, and I consider most of machine learning not learning, it's machine remembering. Learning involves increasing my inference potential. Learning means learning at higher and higher levels, being able to put things together, put inferences together, and learn more and more and more. Continual learning. Neural network is static learning. I train the neural network, and how well it works depends on how well I train it. One of the exercises I'm going through right now for the Navy is I've rewritten the theory of neural networks and we're ripping them apart. Because you train a neural network and you put data through it and you get answers. How many people understand inside of it what it learned of? You don't ever get to see that. You don't know what features it picked out. What we're finding is we start building neural networks a layer at a time and extracting the saliency maps to tell us what did it pick out as features, that there are background features that it uses. Now, how many people think that the same background is going to be there in real data? It's not. So then how do you build a network to eliminate that background bias as much as possible and concentrate on the features of the object you're trying to identify? Dr. Reppy and I talked about noise introduction. I was at a week-long innovation week, and the group showed up. They were very proud. They had a neural network that could identify 47 different targets with 98% accuracy. Guaranteed deep learning network. It's the most amazing thing since sliced bread. I took the model and added 2% Poisson noise to it and identified all 47 as an oscillation. Why? They overfit the problem. Neural networks require massive amounts of data to train. Deep learning networks require tens of thousands of data, tagged data sets. How many think you've got 10,000 tagged data sets for anything? So what do? We play games with one image and rotate it around and move it and try to create 10,000 images out of it, and we train our networks with it and we say we're good. And the first time something comes along that isn't like that, that we can't nail down, we identify wrong. Not saying neural networks don't have their place, they do. They're amazing at data classification, but they're only as good as the data you have. And getting good data, tagged data, is really hard. So we have to understand what works, what doesn't work, how we're using it. And that's why the neural network, and it tells the self-driving car, told it to run over a robot. Now you may not think that means much, except for the poor Japanese research student whose robot just got destroyed by a self-driving car, and was planning on demonstrating it to the world and showing how amazing it was. It's now laying in pieces scattered all over the street. So, what does it mean to learn? Well, it depends on where the learning is taking place. How do you learn at the observed level? Early perception. How do I figure out what features are relevant to learn on, to take in? What can I throw away? Because there isn't enough processor, there isn't enough memory, there isn't enough bandwidth, there isn't enough capabilities to take in and process every piece of every data of every sensor that comes in. I don't care what computer you're running it on, it doesn't exist. Why? Because most of it's not relevant to the context of the system you're using. If I'm doing a facial recognition software at an airport, not that that ever happened, just and I got a camera. Do I care what kind of suit he's got on? No, so I'm going to throw that out. Well, first I have to recognize that it's data I can throw out. So this notion of early perception becomes extremely important. I want to find features that are relevant to what I'm trying to do with it. So now I've got, let's take the human brain. I'm taking in visual data, I'm taking in auditory data, I'm taking in touch data, I'm taking in smell data. How do I use that data? How do I make sure it's relative to what I'm doing? Again, we threw out 95%, which means 95% of each sensor I'm taking and throwing in. So how do I make sure I'm throwing out the right auditory data versus visual data, understanding that those two aren't alike? How do I figure out what audio data to throw out and save the stuff that's relevant to the visual data I'm seeing? Which means there's mini fusion going on in the decision of what data to throw out before I can even start fusing. Multi-sensor fusion, the DoD's been trying to do for, 70 years now? And they still really do it badly. Part of the reason we're tearing neural networks apart is to, if I've got an infrared sensor and a camera, a radar sensor, and a synthetic aperture radar sensor, and I train neural networks on data, odds are every one of those sensor neural networks train on a different feature. So how do I fuse that in the end? By tearing it apart and using an optimizer that says, okay, all you guys try to concentrate on the same kinds of features. That way it makes it easier to fuse. Now I know what data to throw away. how do I orient the data contextually across all the sensors? That becomes a really hard piece to do, but it's crucial to be able to have sensors that can take in data the way the human brain does it and orient. Preconscious buffers. So there's things that happen in the background, there's things that happen in the foreground. There's how I store memory, the meta tags I use for how I store it radically affects how easily I can recall it and recall it in context with other data. So now I've got to worry about and make sure when I create metadata tags to store the data so I can recall it, that they correlate together, makes it easy to pull sensor data that's relative to each other. So now I'm going to worry about this whole preconscious buffer on how I store information contextually across multiple sensors to create metadata tagging. In our brain, it's called triggers. We store memory triggers. We store memory triggers based on emotions. How many people can see, hear a song, smell a smell, brings back a flood of memories? Those are called emotional tags. Those are crucially important to how I tie a bunch of memories together. We have to be able to create those kind of tags in an artificial entity to be able to recall and make decisions. Local associations, orient. I've got to understand how this is relevant to the situation I'm in right now. How is all the data that already exists in my data store and the new data I'm taking in correlate together toward that context? Now, I'm processing multiple kinds of data. Which one gets the most important processing capabilities? I probably can't divide it all out equally and get to anywhere. I've got to give the most to what's the most important parts. Being able to make those decisions becomes crucially important. I've got to be able to allocate resources. Now, if I'm a robotic system, I'm out in the jungle, I'm on the desert, I'm on Mars, I'm on the moon of Saturn. If I allocate all my resources and die trying to solve a problem that hasn't solved anything because now I'm dead. So the whole notion of how do I allocate resources, competition for resources, in the brain it's called cognitive economy. The brain segments how much resources it allows the brain to use for everything it's doing. Understanding, if you take away the resources for breathing, it's probably not going to go well. And the whole point of all of this is just saying that these are things we have to think through. Again, I don't have all the answers, but I'm trying to come up with the questions as a community we need to be asking each other and working toward it. And seeing what technology exists that can be applied to it. What technology doesn't exist, we need to go invent, because most of you are going to be inventing this over the next few years. And then action. So, what does it mean to learn from it? Well, okay, so let's talk about the different kinds of learning that need to go on inside a construct like this to be able to handle all of those things. Contextual learning. I need to understand what kinds of things are important in that context. When I have to make those kinds of decisions when picking that kind of data, here's what's important. And that's different if I have a different context. If I'm in the jungles of Guatemala, it means something different if I'm on Io or if I'm on Mars. So understanding contextually what that means and creating those tags so that when that context comes up, I have a starting point. Case-based learning. Now we saw with the self-driving car, robot, case-based learning has issues. Doesn't mean it's not useful. It means don't base everything on it. Use it for what it's good for. Have multiple learning in it. Match current distributions of decisions. Okay? As I'm learning, I learn these cases. And so the contextual learning helps you build case-based learning. Reinforcement learning. Again, as I do things over and over and they work or don't work, I reinforce or de-reinforce different aspects. I learned that in this situation, that kind of data is important. It's the most important, and I utilize it. And then I say, okay, for a situation that's just a little different, that's not as important, this becomes more important. So over time, you build in tags and reinforcement of what's important across a variety of situations, a variety of things.
Have you asked questions?
Oh, you can ask any question you want anytime. So, go ahead.
You're trying to, seems like that you're trying to, your arguments are all valid if the mission is to build a robot that would never ever make mistakes.
Almost. The whole point is they're going to make mistakes. How do we give it the construct to try to make the least mistakes possible?
Fewer mistakes than a typical human being.
Yes.
So, also the earlier part of your talk, you talked about rules. I just don't understand why very highly reputable, world-renowned scientists invest a significant part of their research time on those rules. And some entities spend a lot of money to come up with those. These rules cannot be enforced.
That's right. Why?
Since they cannot be enforced, why even talk about them?
So, you're driving your car and there's a guy under a street light looking for something. And you stop to help him. What are we looking for? I lost my key. Where'd you lose them? Over there. Why are you searching here? Because it's lighter. Why are they spending that much time on rules? Because they know how to do it. And it'll get them this far. They don't know how to do the rest, and they don't want to invest time and money into learning how to do the rest when they can get 70% there. Now the problem is, what's the 30% that's left? So I agree with what you're saying, and your question is very valid. It's because it's things they can do. Why did Tesla spend several $1 million in 2 years training a neural network? Because he can, and it does a pretty good job. The problem with pretty good is pretty good for a self-driving car is probably not okay. So how many people want their self-driving car pretty sick? How many people want a self-driving tank to be pretty good? But it's things we know how to do, so we do them. But if they, what? Oh, no, please.
Suppose we are in an era that self-driving cars are working perfectly fine. No accidents. Governments come up with the legislation that say from Monday, no car can be driven by humans. They are all self-driving cars, whether the city is dense or otherwise. But then again, there's always going to be that person who's going to go and run to the middle of the road purposely